Hi, my name is Kenny Rains, and today we're going to be talking about inspection data and documentation that you can request whenever you're getting your quote and whenever you're ordering your optics. So I'm inside of our inspection data reference guide, which you can download on our website. We're going to go through here and we're going to talk about the different types of documentation that you can request with your optics. So what comes standard with an order is a material certification, certificate of conformance, coating chart, coating adhesion, and abrasion test. There's a lot of other optional items that you can request, but you do need to request them, such as a first article inspection, coating environmental testing, witness pieces, laser damage testing or certifications, mechanical inspection data, serialization of parts and 100% inspection data reports, interferograms, profiler traces or 3D scans of aspheric surfaces, white light interferometric scans, ROHS certifications, and also the first article inspection quantity will default to the standard AQL level. So with all of that said, what we're going to go into during this talk is what each of these mean and what they will tell you. So we'll start out with the first article inspection, and that comes from AS 9102. And ultimately, what the first article inspection report does is it goes through every single aspect on your print and quantifies it and qualifies it. And so this is an example of a blank first article inspection report. This does cost extra and you need to do it per element. And also, if there's a specific quantity that you need for first article inspection, you need to specify that to us. Otherwise, it will default to the standard AQL level. For coating, we will go ahead and send you a coating graph, and what that will show you is the spectral performance on the optic, on the witness piece, in the run. And so in this case, we have a broadband AR coating, anti-reflective coating. So we have the reflection percentage over here on the left side, and from 400 to 700 nanometers. And we can see that the R average is much less than 0.5%. Even the R absolute is less than 0.5%. And we can also see what the angle of incidence is that this was tested at. So if you want transmission or reflection, you need to specify which one that you need. And also, if you need witness pieces, you need to let us know that. We'll talk about that a little bit more here in a second. For environmental testing, adhesion and abrasion testing are standard with every single run at LaCroix. But if you need humidity, temperature, adhesion, abrasion, salt spray, salt solubility, and cleanability, that needs to be specified, such as with MIL C 48497. For coating witness samples, this is a list we have of the standard witness pieces at LaCroix. If you want the same material, that needs to be specified, and that will likely cost extra. Also, if you need witness pieces, that is okay. We can send them to you upon request. For laser damage testing, there are two different types. There's laser damage certification and there's laser damage threshold testing. Laser damage certification is just your specification tested, and it either passes or fails. Threshold testing means that the lens is tested all the way to failure, and you're given a report that shows you at what point the optic failed. So you would know exactly how much laser damage the optic could take until it fails. For inspection data, you have the geometric tolerances such as center thickness, diameter, sag, the chord or surface quality, all of these different aspects. And then there's the optical side, such as the optical power, the radius, the irregularity, also the surface roughness. So this is our new view white light interferometer that will do a surface roughness scan. In this case, we look at the RMS value, and this specific scan was showing that this optic was roughly 5.5 angstroms surface roughness. We'll go ahead and also take a look at this interferogram, and we can see what the optical power is, as well as the peak to valley irregularity and the RMS irregularity. So if you need to know the RMS value, go ahead and specify that on your print, and we can generate an interferogram that will tell you what the RMS value is as well. Next comes, how do we define an aspheric surface? We do that through profilometer traces as well as 3D scans. So with a profilometer trace, you're taking a 2D sliver of the lens, and you get this profilometer trace if it's requested, and from here you can see your peak to valley form error is this waviness column, and you're looking at peak to valley or RMS, and then slope error, you just give us what the integration window that you're looking at is, and typically 1 millimeter is the integration window size, and you're given a peak to valley and an RMS slope error as well. For the 3D scan, you're getting the same thing, your peak to valley and your RMS as well as your slope error. You're just taking a look at the entire surface of the lens as opposed to just one sliver of the lens. This is the slope error measurement of a 3D scan of an A-sphere, and you can see the peak to valley as well as the RMS value. Then you have the measurement of optical deviation or wedge. This is known with a trioptics optocentric and can typically be reported in minutes and seconds for optical deviation. We also have many other tools such as our Zonix precision CT gauge that will measure center thickness, sag. It'll measure the total height of a lens. And we have several other devices that we use to measure the geometry of optics. We also have a Zygo GPIXP interferometer with a DMI, so that way we can accurately report what the radius is of the surface of a lens. And all of those tools help us to be able to record and report the geometric and optical tolerances of and specifications of an optic. So now, how do we know what material we have? This is where material certifications come in. So material certifications come from our vendors and will certify what the material is, what the index and dispersion is, as well as what the range is of the specific melt. They give you the actual index and dispersion values of that melt. And then also, if you have any special specifications such as homogeneity, bubbles, inclusions, birefringence, different things like that, they will be noted below. So melt certifications are how you know that the material is what it is supposed to be. This is some more melt data from O'Hara. Certificate of compliance just simply means that we certify to the best of our ability that the materials and parts supplied are in conformance with everything that was specified. An ROHS certification or restriction of hazardous substances can be provided upon request. And you can ultimately check out this report and go a little bit more in depth if you'd like. I wanted to just take some time and be able to give a brief summary of the type of data that you can request and documentation you can request. If there's anything that wasn't covered in here, go ahead and feel free to ask us, and we'll help you out to the best of our ability. Thank you for your time.